But is it wrong though? Because I'm supposed to get 6, yeah? It's not wrong. Well, I'll show you why it's not wrong later. The slope is negative, yeah? So BC is equal to, what I get? I got minus, what was it? Minus 3 divided by 6. That's minus 1 divided by 2i. Plus, what's delta y? Delta y was 3j, right? If you multiply it through by, if you multiply it through by 2, so 2 times BC is equal to negative I plus 6j. Okay, so this is the dilemma. I said these two should be scalar multiples. But the sad part is, this one is negative and this one is positive. If I multiplied by -1, that means I'm flipping the vector the other way around. So I have to still modify this properly. I don't think I'm doing a very good job of modifying it. So follow me the way I'm doing it. So I want this slope to be equal to the difference between these 2 points. The slope of these 2 points must be equal to the slope of these 2 points. But now we have to follow me. I want the difference between y and y1 to be 3, right? So I have delta y is equal to 6 minus 3, that's 3. And I want delta y to equal, divided by delta x to be equal to 6. 6, right? I know x1, I know x2. x2 is equal to 3. So I know that delta y for me is 3 divided by let there be light. I know x2 is 3. 3, so an x1 is unknown. That's what we're looking for. So 3 divided by x2, what's x2? 3 minus x1 is equal to 6. If I cross multiply, I know 6 times 3 is 18, and 18 minus x1. Sorry. 18 minus 6x1 is equal to 1. So it's equal to 3. What am I doing? It's equal to 3. Yeah. And 3, oh, I see my mistake. Where did I get 21 from? And 3, so if I take 3 here, so it becomes minus. So I have 15 is equal to 6x1, right? And x1 is equal to 15 divided by 6. Hence, if I have x1 to be equal to 15 divided by 6, I have that delta y. So let me do x2 minus x1 now. That's 3 minus 15 divided by 6. And that's 6. And that's 18. And that's 15. So I have equal to 3 divided by 6 equal to a half. And delta y is equal to 3. So if you flip that, so you have 6. Yeah, so now the modifications. Sorry for wasting your time, but I just want you to see how my reasoning is going trying to modify this point so that the slope will be equal to 12. I'm trying to do this quickly here so I won't waste the video's time. But I kept making mistakes, so algebraic mistakes. Everyone is prone to algebraic mistakes, trust me. So I know that BC is equal to, what's my delta x? My delta x is a half times I. Yeah, this is what I'm looking for. My delta x is equal to a half times I plus, what's my delta y? My delta y is 3, isn't it? It's 3j. If I multiply, okay, so this is the idea. I'm not going to multiply straight away. But look, I want CD, I guess I should write this here. I want CD to be a scalar multiple of BC. So I want CD to be equal to some number. I know what CD is. I know what CD is I plus 6j. CD to be some number times BC, and BC is a half times I plus 3j. What would this number be? Obviously, I want lambda times, so I want lambda divided by 2 times I to be equal to 1, obviously, and I want lambda times 3j to be equal to 6. You can already tell what lambda is going to be. Lambda is going to be 2. So in this case, the scalar multiple is 2. Now, we're going to define something called the cross product. So I'm just throwing in all these terms. Later on, as I go further, I'll go into like the gritty meanings and derivations of things like dot product and things like scalar multiples and so on and so forth. I know that the scalar multiple in this case is 2. That's what scales the vector up. Now, let's define some things. Let's say that the vector CD is equal to just one entity A, and the vector BC is equal to one entity B. I'm just going to give you like the definition of a cross product without just accept it. Okay, please. If I take the magnitude of A cross B, that will be equal to the magnitude of A multiplied by the magnitude of B sine times the angle. I'm going to show you a property of collinear points. There's a general property that all collinear points must always have. And this is where I'm going. So follow me very well. I'm trying to bring everything up in my head as I go. So this is a definition of a cross product, yeah? Keep this in your mind. Sine theta, so yeah. Now let's find three things. Let's find the magnitude of A, the magnitude of B, and the angle theta. I know something. I know that A dot B is equal to magnitude of A, magnitude of B, cosine theta. Right. So okay. There's something I'm going to show later on. You can use that. You can use a matrix determinant to find what A cross B is and take the magnitude, but that's not necessary. So there's something I want to say quickly before I go on. So just know this: if you take the cross product of two vectors, they give you a third orthogonal vector to the original two vectors that you crossed. If you take the dot product between two vectors or of two vectors, you get a scalar function or a scalar factor. Now let's say what's A? A magnitude of A, I mean, is equal to 1 plus 36 square root, that's equal to root of 37. Later on, I'll probably do invariant lengths in space. This is the, what's it called? The analog of what we define as space-like separation in special relativity. So in coordinate space geometry, we call it the length squared, which is called an invariant. So it doesn't change for different observers, but that's not important. So B is equal to 1/4 plus 9. I know what the answer is, but I just want to write it in a fraction. I just want to write it in a fraction. 4, 1 plus 36. So that'll be, it's obvious what the answer is gonna be. Why, I didn't even have to do that. That'll be 1 divided by 2. If the scalar factor, where is it? Did I clean it? So lambda is equal to a half. Is it? Wait, what was? Well, I'll get that later. Square root of root 37. Yeah, obviously, Oscar. Yeah. Anyways, that's half of, square root of 37. So that'll be the length, the whatever. So A dot B on its own is like the idea of a Cartesian product. So that'll be 1 times a half, that's a half, plus 6 times 3, that's 18. So you have that to be 2, 1 plus 36. So that we have 37 divided by 2. Yeah, divided by 2. So that's the dot product. So I have 37 divided by 2 is equal to this, multiply these two numbers, so that's 37 divided by 2 cosine theta. Cos theta is equal to 1. Theta is equal to 0 or pi. That's all, or 180 degrees. So theta is the angle is equal to 0 degrees or pi. I think in my previous videos I showed why the case why it is the case that theta is 0 or 180 degrees. So we know what theta is, we know what b, and all of that is. So we can clean all of this nonsense. All right, now I'm getting to like a real definition of collinear points, a real property of collinear points on the same. Well, obviously it's implicit in its name, collinear points. So it's points aligned on the same line. So now we can do some definitions. So A cross B, magnitude of A cross B is equal to, this was equal to 37 divided by 2 sine 0, or A cross B is equal to 37 divided by 2 sine 180 sine pi, for it to use pi. this is a defining definition of all collinear points. The answer is always equal to 0. So take two pairs of collinear points. Take the cross product, the magnitude of the cross product. That will give you an answer 0. So that's a defining property of collinear point. So I'm sorry I wasted time to do all of this. It's not too. I just wanted to get. I wanted to use slopes to define it at first, but then I thought about it like, okay, I guess I could use vectors and that'll be more efficient. That'll be more sufficient to use. So that's about that. Defining property of collinear points. We said the cross product between any pair, the magnitude of the cross product between any two pairs, of collinear point that these points that lie on the same line is equal to 0. Now, forms. I really wanted to get into perpendicular bisector today, but it seems I can't. So, last thing I want to do. Equation of line. First things first. Y slope y-intercept form. I'll start writing it. So the first one is going to be so I have a graph. So I have some arbitrary point here, x, y, and I have a point here, 0, c. I know one thing for sure. I know that slope is equal to delta y divided by delta x. Then m is equal to, let's write it more explicitly, so it's y minus c divided by x. Hence, cross multiply, you have y minus c is equal to mx. If you solve for y is equal to mx plus c. Done. Easy, yeah? Second form is equal, it is, Jesus Christ, I said equals the slope and x-intercept form. If I have some arbitrary point and the x-axis, this is point k, 0, because the y value here is obviously going to be 0 because it intercepts the x-axis. So, and the slope is the normal delta y divided by delta x, and that's equal to, there's an arbitrary point here, x, y, is equal to y divided by x minus k, in which case mx minus mk. You know what, let's write it like this. So yeah, delta y divided by delta x is equal to the slope. So delta y, that'll be y is equal to mx minus mk. Yeah, so that'll be that. You can factorize the amount. That'll be mx minus k. But you can see something though. We know that y is equal to mx plus c. Y is equal to mx minus mk. Therefore, we can say that trying to say? MX. So I'm trying to say that. Yeah, so minus mk is equal to c. So what I'm trying to, so the conclusion is that the x-intercept, so the y-intercept divided by the x-intercept is equal to the negative of the slope, the negative value of the slope. So if this turns out to be a positive number, just know the slope is negative. If this turns out to be negative, then the slope was initially positive. So those are the first two forms. The third form is going to be like 2 points slope form. So you have a graph that has 2 points, x1, y1, x2, y2. Therefore, take a generic point, subtract unknown points is equal to the y2 minus y1 divided by x2 minus x1. All of that multiplied by, take a generic point and subtract a known point from it. This is actually the equation of a tangent line. So that's another one. Asterisk. The fourth, guess I'm cleaning it already anyways. Fourth way is the x and y intercept form. X and y intercept form. Actually quite simple. It says the x divided by the x intercept plus the y divided by the y intercept is equal to 1. That's simple, very, very simple. What I'm trying to say is that x divided by k plus y divided by c is equal to 1. So kc is equal to x plus y. Oh no, that's a mistake. Kc is equal to xc plus yk. So that's another asterisk. So that's x and y intercept form. And the most important form, which is the first one I was supposed to write anyways, 5, which is the general form. Ah, Christ, what has just happened to me? Yeah, let there be light. Yeah. This is supposed to be the first thing I should have written. So general form, which is ax plus by plus c is equal to 0. Which was the way I was actually writing in the first place when we were actually doing those examples. Yeah, so yeah, that's about that. I think, yeah, is there any other form? Yeah, I think that should be it. Yeah, so that's about it. Let me see how long. If I've passed 40 minutes, which I think I already past 40 minutes. Guess we call it a day today, and then I'll start from the midsection of a line, or midpoint of a line, and that transposes, I guess, into perpendicular bisectors and stuff. So, thank you for watching today's video. I know it was I messed it up a little bit when I was talking about collinear points, but thank you for watching and bearing with me for those mistakes that I made. Thank you, like, share, subscribe, and tell other people about it. Bye.